So very first thing is we're going through determinants and inverses. A couple of things that we've got to kind of get out of the way. A couple of, I guess, ground rules we've got for this one. Yesterday we talked about the additive identity, which was a zero matrix. If you took a zero matrix and added it to another matrix, you'd get the same thing back. The first thing we've got here is the identity, the multiplicative identity matrix. And somebody came up with a great shortcut for this one. They said, okay, we're just going to go capital I. Okay, and depending on the size of the matrix, and these are always going to be square matrices when we're looking at this. If it's I2, it's going to be a 2 by 2 matrix. The multiplicative identity, it's always a fun word to say, is 1001. The multiplicative identity matrix, if it's 3 by 3, anybody want to say multiplicative with me? Multiplicative. It's just a fun word to say. It's just a fun word to say. Okay. There's just no song with multiplicative. So, okay. So if it's a 3 by 3 matrix, it's 100010001. So basically, it's always 1 on the diagonal. If you go through this one, if it was an I4 matrix, it would basically be 000 and then a 1 here. So it's always on the diagonal if you go through this one. If you had a 5 by 5 matrix, same thing. It'd just still be ones going down the diagonals as you go through those. Okay, so what all that is leading up to is basically this. If you multiply, and again, capital letters are matrices. So if you multiply matrix A, let's put the word multiply in there. If you multiply A times B, or B times A, either one of those two, if you multiply those two matrices together and you get one of these multiplicative identity matrix where you get your diagonal is 1 and everything else is zeros, we'll just say it this way. The matrix B is the multiplicative inverse of A. So if you multiply A times B and you get the identity matrix, then basically they're inverses of each other. And remember, we're just inverse operations. So instead of +2, it'd be a -2. If we were doing square roots, like we were doing in the last section with all the rational stuff, if it was square roots, it was x squared. If it was third root, it was x to the third, those kind of things. So in this case, if you multiply these together, that's the multiplicative inverse we're going to. And if those are inverses, how they show that is they're going to show that with an A to the -1 power. So anytime you see a -1 power, just realize that's asking, is it inverse? Okay, and there's two questions. The first one should be, and going back to the multiplication, that's why we're reviewing multiplication before we went through this one, is that with the first one, we're going to give you two matrices and ask you, are these two matrices inverses? So A is 1154. And then B is -41, 5 -1. Okay, and according to this one, if we do A times B or if we do B times A, it doesn't matter. Then as long if we get back a matrix that is the 1001 for this part, then they're inverses. And that's what we're just going to check and see. Okay, so let's just see what A times B is. Okay, so again, we're going to go 1 times negative 4, 5. So 1 times negative 4 is negative 4. 1 times 5 is 5. So negative 4 plus 5, that is a 1. Okay, so far so good. Because again, we need 1, 0, 0, 1 if it's going to work out this way. If we do the first row times the next one here, we've got 1, 1 times 1, negative 1. So 1 times 1 is 1. 1 times negative 1 is negative 1. 1 minus 1 is 0. So that one's good there. Okay, second matrix. When we do 5 times 4, or 5, 4, times negative 4, 5. 5 times negative 4 is negative 20. 4 times 5 is positive 20. That one's 0. So far, so good. So if that last one comes out, that this last corner here is a 1, then we're good to go. If it's not a 1, then they're not inverses of each other. Okay, so the last one we're going to do 5, 4 times 1, negative 1. So 5 times 1 is 5. 4 times negative 1 is negative 4. That does give us a 1. So we've got the identity matrix here. So are the inverses? Let me say yes, they are. Okay, do one more of those where we'll do one where we see that's not an inverse, just so we can take a look at it. And then once we've got one that's yes and one that's no, then we should be good for him. Again, that's for any size. For everything we're going to do, we're looking for basically these. So we're looking for square matrix, whether it's a 2x2 or a 3x3. We're not really going to worry about a 4x4 because that's just, going a little bit above and beyond there. All right, so for example 2, A is going to be 3, 2, 5, 4. And B is going to be 2, negative 1, negative 5 over 2, and then 2. That's negative 5 over 2. Throw a fraction at you. We haven't looked at anything with a fraction yet, so just got to throw it in there just to be on the safe side so that nobody freaks out too much. Okay, so for this one, we're doing 3, 2 times this one. So again, our answers should go right underneath it here. So if we do 3 times 2, that is 6. We do 2 times negative 5 over 2. The 2's will cancel and leave us with a negative 5. So that would be 1. Okay, so when we do 3, 2 times negative 1 over 2, that's 3 times negative 1 for negative 3. 2 times 2 is 4. Also gives us 1. But that has to be a 0. So because this has to be a 0, then we can just stop right there. Okay, so you don't have to go any farther. They're just going to ask you yes or no. Now, probably what it's going to ask you in some of the homework questions is it's going to be a yes or no type question. And if it's yes, they're going to say, all right, now tell me what is the inverse of it. So you go, if it's no, there's no. There's nothing that you can do to it. But if it's yes, then you can at least then go on and tell me, all right, if it is, then tell me what the inverse of it's going to be. Okay, so that's inverses. It's just taking two numbers, multiplying together. And again, if you get one's on the diagonal and zeros everywhere else, then they're inverses of each other. Okay. And then we've got one other thing we got to talk about, and then that will lead us into tying in the two things together to figure out how. So basically, we're going to show you how to find the inverse of a one that's there. So taking two, multiplying it, we got it. We need to show you how to find the inverse. And this is one more step we've got in between here. So. Okay, so we're going to find the determinant of a square matrix. And for determinant, they get tired, math people get tired of writing long words out. So for determinant, they're just going to call this thing short. They're just going to call it DET. Because math people are really kind of lazy, so we come up with all kinds of shortcuts that we can do stuff. Just like if you write out the word parallel, that's the symbol for parallel. It's just two letters, just two slashes. Instead of writing out the word perpendicular, make it a T. So, math people are usually pretty good about taking some long word and trying to make it out to be a little bit shorter. So. Okay, so here we go. All right, so you got matrix A. And I'm not going to give you numbers for now because I'll show you just because it's a quick, short little way to get there. So if matrix A is this one, then the determinant of A. Now, when you do this one, leave a little bit of room above it because we're actually going to work above this one. It's going to be doing cross products, but you're going to have to multiply up instead of multiplying down because most time we do cross products, we go down. If we're going to do determinant, we're actually going to go up. We're going to do A times D and put that answer here. And then you're going to subtract B times C. So you're basically just doing cross products. But again, you have to remember for determinant, you need to go up instead of going down because normally we go down to get those, but we're going to go up for this part of it. Okay, really short, really easy. There's how you find a determinant. Is basically you just multiply this way, and then you put a minus sign in the middle. All right, so let's put some numbers on it now. So if A is 2, 5, negative 4, 8. And they ask you to find the determinant of A. Again, just cross products. We're going to do 8 times 2, which is 16, and then minus negative 4 times 5, which is negative 20. So you've got 16 minus negative 20, which is really 16 plus 20. So then your determinant is 36. Okay. Everybody good with that? Pretty straightforward, right? Okay, now 2 by 2s, really easy, really straightforward. So I can give you a lot of those because those go pretty quick. A 3 by 3 matrix. This is probably one question in the homework and maybe one question on the test because any more than that, it's just going to take a long time to get through those. So don't think that you're going to have just a ton of these as you go into the homework because I'm not because they're a little bit time consuming. So they're going to be maybe one in the homework, maybe one on the test. Okay, 3 by 3 matrix. I'm going to start on your sheet because it does take a little bit of time. So everybody just kind of hang with me here. Okay, so if we're going to do a 3 by 3 determinant, here's what we're going to do. We're going to basically use A's and B's and C's because, I guess we could use different letters. A lot of times you'll see it in most examples, they use like A1 and B1 and C1 and A2 and B2 and C2. For this one, let's just use all different letters. We're going to go A, B, C. We're going to go D, E, F, G. I hate to use H and I, but we're going to go ahead and use H and I. Okay, so how can you do cross products if it's 3 by 3? I mean, you could do it here and here, but you're leaving off the D and the B and the H and the F. So what we're going to do for this one is, if you've got a 3 by 3 matrix, what you have to do is you've got to rewrite it first. And again, leave a little bit of room above it here because we're going to show all the work above it when we're doing this part. So go ahead and do A, B, C, D, E, F, and then G, H, I. And then basically you're going to take the first two columns you've got here and then rewrite them here. So go ahead and give me an A, a D, and a G, and then a B, and an E, and an H. And the only reason we do that is that so then now we've actually got numbers that we can go back and multiply together. So then we're going to multiply cross products, but we're going to have to do it for all of them. So we're going to multiply A times E times I, and that will go here. And then we're going to add that to G times F times B, or B, F, G, doesn't really matter there. And then C, D, H. So multiply. So basically, we're still going to do the same thing. We multiply like we're going to multiply here, but we'll need another one here, another one here. So basically, we're just moving these numbers over here so we can multiply those out. So it's A, E, I, B, F, G, and then C, D, H. We're going to add all those together, and then we're going to subtract everything now going in this direction. So that would be G, E, C, H, F, and A, and I, D, and B. Okay. And again, you're not going to get a ton of these in the homework. You're not going to have a ton of these on the test. It's probably one in the homework just to get you some practice. And again, at most one on the test just because it's a little bit time consuming as you go through this. Okay. So again, it's still everything on the diagonals. It's just we need to put the missing pieces here so we can multiply this way. We also got to put a couple pieces up here so we can multiply it out that way. All right, so let's give you one with numbers. And again, we're only going to do one because after one, it's too much. It's a lot going on. Okay, and go ahead and leave some room above it because we're going to, instead of rewriting it twice, we're going to give it to you once. And then we're just going to add on to the end of it. Let's go 103. We'll go 246. 5, -1, and 3. And I'll scoot it up so you can see it. Okay, so what we're going to do, instead of rewriting it, we know that's the original part that we've got. So we're going to find if this is A or whatever we're going to do. If we're going to find the determinant, all we're going to do is we're going to take the first two columns and just rewrite them over here beside it. Okay, and again, here's where you take your time. Don't get in too big a hurry so that you don't mess anything up. We're going to go to the up and to the left first. So we're going to do 3 times 4 times 1. That's 12. We're going to do 5 times 6 times 0. And that 0 is nice because if you've got a 0 in there, well, we know that's going to be 0 because, you start multiplying. We've got -1 times 2 times 3. That would be a -6. and then we're going to go minus everything back here. We're going to do 5 times 4 times 3 is 60. Negative 1 times 6 times 1 is negative 6. And then 3 times 2 times 0 is 0. Okay, so our red numbers. We've got 12 minus 6, which would be 6. We've got minus, and then in the parentheses, we've got 60 minus 6, which would be 54. So we've got 6 minus 54, which is negative 48. So our determinant in that case would be negative 48. So again, determinant is just finding a number value if we're going back and doing cross products on this thing. Okay, now here's what that means. Here's what we're looking for these. If whatever matrix you're doing, if you do the determinant of that matrix and it equals 0, then the matrix does not have an inverse. Okay, anything other than 0, you can find the inverse of that matrix. But if whatever matrix you're working on, if that, whether it's a 2 by 2 matrix, a 3 by 3 matrix, 4 by 4, it doesn't matter. Whatever matrix you're working with, if determinant equals 0, you cannot get an inverse of that particular matrix. Anything else, you can find out what the inverse is going to be. Okay, so what we're going to do, we're going to show you how to get the determinant of a 2 by 2 matrix. We're not going to worry about a 3 by 3 matrix because that gets a little bit more time inclusive, and there's a lot of stuff with that one. So we're just figuring out determinants of a 3 by 3 matrix. We're not actually going to find the inverse, but we are going to find the inverse of a 2 by 2 matrix because it's not too bad. Okay, we're going to do that on we start a new page here. Okay, here's the last big thing of the day we got. So to find the inverse of matrix A, when A equals, and we'll just go back to our letters, A, B, C, D. The inverse of A, and again, inverse is going to be A negative 1. And to get the inverse of A negative 1, which is what we're looking for, it's 1 over the determinant. So basically, we're going to go back and do our cross products here and figure out what that number is going to be. So it's going to be 1 over that number, and then you're going to multiply it by, and here's the pattern. You're going to switch these two numbers. And then these two numbers will stay in the same location, but we're going to change the signs. All right. And again, we're not going to worry about 3 by 3 matrices. That's a whole nother, that's a big giant step from there. We're just going to stop with 2 by 2s because this one's actually fairly straightforward. So do your cross products first, figure out what that number is. It's going to be 1 over that number, and then you're going to multiply that by, you're going to switch these two numbers and then change these two signs. Okay, so here's our question. We'll do a couple examples and we should be good. Does the matrix have an inverse? And then if yes, find the inverse. Okay. Again, we're going to leave that formula right there because that's the one we're going to need. You can leave a little bit of room above it because we're going to actually show our work up above it here. I guess we'll do over the side of it. Okay, so that's matrix A. The very first thing we have to do is we have to figure out what the determinant's going to be. So to do that one, again, we're going to take that same matrix we have here and do our cross products. But again, when we do the cross products on this one, we're going to go up. So it's 4 times 2, which is 8, minus 3 times 2, which is 6. So that's 8 minus 6. So the determinant is 2. Okay, and again, anything other than 0 means we can find the inverse of it. So yes. Does the matrix have an inverse? Yes, it does. Okay, and then to find that answer, to find the inverse of matrix here, we're going to have to take 1 over this determinant, which in this case was 2. So it's going to be 1/2. And then we're going to, again, these two numbers, now what we had that was A and D, we're going to switch these two numbers. So we're just going to switch locations. So what was 4, 2 is now going to be 2, 4. Sorry, a little crooked. So again, we're going to switch these locations. And then whatever these numbers were, we're going to change the sign. So change this to a -3 and a -2. Okay, so we're going to take everything on the inside after we've changed these and changed these signs. We're going to take every single number in here and we're going to multiply it by 1/2, or we're just going to divide everything by 2. So dividing all those numbers by 2, we're going to get 1, -1. We're going to get 2, and then -3 over 2. Okay, so let's do this for one more of these. Let's see what we can do here for. Everybody good there? Everybody still copying that one down? Okay, so let's start with this one. First off, let's go ahead and figure out what the determinant is going to be. Actually, y'all do this first. Y'all go ahead. Y'all tell me what the determinant's going to be. We'll pause for a minute. Because again, if you do your cross products here, we've got 2 times -10, -20 minus -4 times 5, also -20. That's -20 plus 20. That is 0. So determinant equals 0. This does not have an inverse, so we don't have to worry about doing anything with this one. Okay. And then what we'll do, one more thing. And this is kind of a neat thing that I didn't know how to do this one until I don't think I learned how to do this one way back when. You can actually find the area of a triangle. Using a matrix. It's actually pretty neat when you see this one. So there, some people are like, where are we ever going to use matrices? It's an actual real life application. You're like, well, am I ever going to find the area of a triangle? Well, if you do any kind of construction, business work, anything, you're finding an area of a triangle a lot of times, and this is something you can do to kind of go through this one. So to find the area of a triangle, especially if it's not a right triangle, if it's a right triangle, it's pretty easy. It's length times width. You need to divide by 2. If it's not a right triangle, this will help you find out what that area is without having to do any other weird things with it. So if you're going to do that, it's still going to be 1/2. You're going to do the determinant of A. You're going to take the absolute value because, again, it's area we want it to be positive. So if your determinant happens to be negative, we're just going to make it positive. So it's going to be area is going to equal 1/2 times the determinant of A. You're like, what else? That's it. So you're going to find the determinant of that triangle you have, and then take the absolute value of that. If it's negative, make it positive, and then cut it in half. All right, now the catch is when you do the matrix A for this one, because you're like, well, if it's a triangle, we know we've got 3 corners, right? So you got your first corner of your ordered pair, you've got your second corner of your ordered pair, you've got your third corner ordered pair. So what we're going to have to do basically is we're going to put 1s over here for placeholders. To basically make it a 3x3. And now we're going to go back and use our 3x3 determinant rules that we had to then put this thing in play. And we're going to go, cross products and cross products and cross products, and then we'll go this way. So that's where you're going to have to use that 3x3 matrix to go back and figure out what it is. So might be a good bonus question on the test, maybe, possibly. Don't know. Or it could be a good application question anyway, at least. Okay, so here we go. Last problem of the day. So find the area of the triangle with vertices 1, 3, -3, 0, and 5, 0. Okay, so here's what we're going to do. Just put those in a matrix. Ooh, again, leave a little bit of room underneath it because we're going to have to work above it. We've got 1, 3 for the first point. And again, just put a 1 over here. I don't know why I put a comma there. Then we're going to do -3, 0, and put a 1 for a placeholder. And then we're going to do 5, 0, and then put a placeholder. So ordered pair, ordered pair, ordered pair, and just put 1s at the end of it. Okay, and again, because it's a 3x3 matrix, we're going to have to go back and repeat these first 2 rows. So we're going to put a 1 and a 3, -3, 0, and then 5, 0. So we're going to repeat our ordered pairs on the outside so we can go back and do our cross products here. Okay, so then we're doing cross products. It's 1 times 0 times 1, which is good because that's just 0. It's 5 times 1 times 3, which is 5. And then it's 0 times -3 times 1, which would be -3. Yes. Oh, it is. Thank you. Thank you. It is 15. Okay. Going the other direction. We need a minus And then it's all these things over here. So we've got 5 times 0 times 1, which is good because that's 0. We've got 0 times 1, which is also 0. And we finally get one number at the end here. We've got 1 times negative 3 times 3, which would be a negative 9. So we got 0 plus 15 minus 3. That would be 12. Minus with the zeros on the inside, that's negative 9. So 12 plus 9, not 12. Is that right? Yeah. Something's off there. What did I do wrong?
The negative 3 should be a 0. So we multiply by 0.
Yep, there we go. Thank you. I was looking at it. I was like, something's off there. So, yeah, it's a 0 there. My bad. So that's not 12. That's 15. Yeah, I was looking at that. I was like, something doesn't seem right there. Sorry about that. That's my bad. So it's basically 15 plus 9. So that would be 24. Okay. And then the area is 1/2 times the absolute value of that number. Now it's positive, so it works out pretty nice in that case. So it's just half of 24. So that would be 12 square units. Okay, it may not be the best thing in the world, but if it's not a right triangle, then that's a actually fairly good way to figure out what the area is going to be. If it's a right triangle, obviously you won't have to do that. But if it's not a right triangle, that's your direction you can go about to find out what the area is going to be.